All right, so in the interest of time, I'm going to keep going. So our next speaker is James Graham. Welcome, James. James is joining us from London today. He works at Mozilla, and he's been involved in defining a lot of web standards over the last decade. So I'll hand it over to James.
Okay, I have a microphone. I'm good. Okay, great. So hi, I'm James, and I'm going to be talking about how we've been using test automation at Mozilla to improve the web for everyone. So it's kind of hard to introduce the web, right? Because it's become so completely ubiquitous that there's sort of nothing new to say. But I think it's worth re-emphasizing the point that really it's the most important application delivery platform in the world. It's the only thing that you can get on any consumer electronic device that you buy, from your tiny smartphone or whatever, right up to your TV. They'll all be able to access web content. And in the 25 years that the web's been around, we've come a long way. So this is pretty much the first web page, and it's some text and a few links, and it has the most important features of a web page. But now we're doing cool stuff like this. So this is, for those of you that don't know, this is a screenshot of Firefox OS, which is a whole operating system where the user land is purely written using web standards. So everything you see there is just HTML, CSS, JavaScript. But you could also substitute in your own favorite complicated web app here. You might want Google Maps or whatever you think is a neat thing that's delivered via the web. And this is pretty cool, but there's a problem. And if you speak to any sort of web author, they're going to tell you about how awesome it is when they get their site running for the first time in their favorite browser, and they've maybe been coding this feature for a little while, and then they load it up in their second favorite browser, and there's this crashing sense of disappointment, right? Because suddenly the whole thing that was working so well is completely broken, and they have to spend time figuring out, well, what went wrong. And you even see this on production websites. So what I have here, and I guess you probably can't read it, is a screenshot of the error console from two different browsers, so from Firefox and Chrome, actually, for one production website. And what you can actually see is that in both browsers it's showing errors, so you can maybe just make out that there is some red text. What you maybe can't see is that the errors are completely different in the two browsers. So, we don't know if this is because it's sending different code to the different browsers to work around some problem that they thought there was in one of the browsers, or if the browsers themselves are behaving differently given the same input. But it's difficult, and this is a ubiquitous problem. Once you've worked on browsers for a while, you get pretty tired of finding sites that work in one browser. They work in IE6 or whatever, but they don't work in your supposedly better browser. And it's really difficult to diagnose. So you have to spend ages and ages digging through the source code of this site, hundreds of kilobytes, megabytes sometimes of JavaScript to work out what's gone wrong. And if you want to make a better browser, then that sucks. That's not a scalable solution. So this sort of lack of interoperability, it sucks for authors who have to spend twice as long as they would like trying to make cool things, and it sucks for browser vendors who are trying to make the web better. And it sucks a bit if you have a big browser with lots of market share, but if you're actually trying to do something new, then it sucks even more. So this is a screenshot of Servo, which is a Mozilla research project to try and make a next-generation browser engine that uses parallelization to speed up rendering. And the idea is that sort of current browser engines in the future won't be able to take advantage of the kind of hardware we expect. But what you can see here is that rendering a rather simple page, like the Google home page, it's not doing a great job, to be honest. And if, to develop this browser, they have to, every time it looks like this, they have to go, OK, I'm going to dig into the source code of that page to figure out what's wrong, then it's going to take them an awfully long time to get anywhere. So this lack of interoperability is really terrible for the current web, and it's terrible for the future of the web. Something has to be done. And maybe it's no surprise in this venue that I'm going to suggest that the answer is testing. So in order to improve testing on the web, there's this project called Web Platform Tests, which is being led by the W3C under the sort of banner of Test the Web Forward. So some of you may have heard of Test the Web Forward. It was a sort of series of events that was being run to get people into testing for the web, but now it's actually the general name used for all web platform testing that's being done at the W3C. And this site, testthewebforward.org, has all the documentation on how to write tests and is generally a useful resource if you want to later find out some detailed information about the things that I'm going to introduce now. And so the idea of web platform tests is that it's a collection of test cases written to work in all browsers to try and address this interoperability problem by giving them tests to work against rather than having to reduce pages every time that they find a bug. And the idea is that browser vendors will contribute their tests, and also authors, if they run into some bug when they're trying to get something working in a new browser, can contribute a test and say, look, browser vendor, here's a test that I've put in a test suite that you're already running, please fix. And if you've ever contributed to an open source project, contributing to web platform tests should be fairly familiar. We have a GitHub repository, we take pull requests, we do code review, blah, blah, blah. It's designed to be completely straightforward. And the key point here is that it's testing for interoperability, that it's really testing to make sure that browsers all do the same thing. And that might sound obvious given the introduction I've given, but it's actually a sort of new idea for browser vendors. So historically, the W3C has done something called testing for implementability. And the idea behind that was that as part of their process, you have to have you have a test suite, and 2 implementations have to pass every test in order to be allowed to advance that specification along what they call the recommendation track, so for it to become a proper specification. And the problem there is all the incentives are terrible, because the people writing the tests are probably in the working group. They want their spec to reach recommendation. They want to write the simplest test they possibly can that nobody will fail. And browser vendors typically have done something slightly different. They've typically written regression tests for their own browser. So every test must pass, and if our behavior doesn't match the spec, well, then we write a test for our behavior rather than a test for the spec. In this case, we're trying to do better. We're trying to write tests for the spec, but we want every evil test case that you can think of, because we want to fix problems. We don't want to, just advance specs along some bureaucratic path. And how are we doing? Well, based on the number of top-level directories in the repository, we have tests for about 60 specifications. There's about 3,500 test files, which produce a little over 200,000 test results, and we have no idea what this means in terms of coverage. And that's a pretty interesting question that, maybe it's worth talking about afterwards. So here I just have a simple example of the kind of test we have. So most of these tests, the vast majority of them are written in JavaScript, although we also have some that aren't. JavaScript tests are written using this framework called testharness.js, which is pretty much unique to web platform tests. But one of the early decisions we made is we're not going to take tests from every different browser vendor, every different contributor in whichever format they like. We're going to standardize on one format, and instead of saying, we'll take QUnit tests and Mocky tests and whatever your favorite is, we'll just take test harness tests so that it's easy for everybody to read all the tests. So we have a simple page here. One interesting thing is we have this test harness report.js. That's upstream, basically a blank file. And the point of that is that it's a extensibility point. So if you're a browser vendor and you want to run these tests, any code that you put in test harness report.js will never conflict with upstream. You can always extend it there however you need to report to your continuous integration setup. If you've ever used a sort of XUnit style framework, it should look pretty familiar to you. We have just a script here with a function called test, which itself takes a function, and inside that function we have this assert equals function, which just tests two things for equality, and if that assert doesn't throw, then the test passes. We also have this concept of asynchronous tests. A lot of the web platform is asynchronous and depends on events or promises or whatever. So the example I have here is just a test that the load event fires when the document is done loading. And so we call this async test function with a test name, and it will give us back a test object. And on that, we have this sort of step function thing. And in this case, what it's saying is, when on load fires, give me a function back that will be called, and it will basically run this t.done, which basically marks the test as done. So that's maybe not very obvious in my 30-second overview, but like I said, there's a lot of documentation if you want to get into this. So that's the client side of testing. But of course, for testing websites, you need a server side. And this is a bit more difficult. So looking at the prior art here, every browser vendor did something completely different. So the W3C, for example, had a server running using Apache and PHP, which they were also using at Opera. Mozilla had something called httpd.js, which is actually a web server written in JavaScript using internal Firefox APIs. And the less you know about that, the better, really. And they also use Python for some things. I think that Blink uses light HTTPD and PHP. People use Node. I'm rather sure Microsoft used something .NET based, but I have no idea what. And so on and so forth. So we needed to pick something to do here. And when you have this kind of decision to make, it's always a good idea to start by looking at, what are my requirements here? So for writing a test server, one of the first things you need to be able to do is you need really precise control over what actually gets sent in your test cases. So a normal HTTP server will really want you to send something that looks like HTTP. But if I'm writing a test and I really want to claim that the content length header, say, is 100, but I only actually send 50 bytes of content on the wire, and I want to check that the browser does whatever it's supposed to do in that case, then I should be able to do that. So that immediately eliminates, it turns out, most existing servers. Similarly, you need control over timing. So a typical thing might be if I'm testing, say, script loading, then I might have two scripts that the browser should start loading at exactly the same time. But I want to make sure that they're returned in a certain order, maybe to check that they execute in that order or something. To do that, I might want to delay the response from the server by 1 second for a particular script. So that's a requirement. And this is a big open source project, right? Or we want it to be an open source project. And we want it to be easy to run these tests locally. Just on your local machine, no external dependencies. We want it to be easy to run them in automation, so no external servers. So we don't really want it to be necessary to install Apache or something that's stupidly hard like that. And doing simple things should be simple, right? That's a good principle to have in life. And in this case, what I mean by that is if you just want to serve an HTML file, you should just be able to stick it in a directory and have it be served. You shouldn't have to configure routes inside the server or something complicated just to write a simple test. So the solution to this was to roll our own. What we came up with was wptserve. So you'll notice that I'm really poor at naming things. We've had web platform tests, which was a test suite for the web platform. We now have wptserve, which is a server for the web platform tests. And so the central idea here is that it's a Python-based server that's specifically designed for testing. And one of the things we noticed is that PHP is actually quite good for lots of testing use cases because you can just write a .php file, shove it in a directory, and it will work. And we wanted to replicate something like that, but for Python. So we have a very similar idea that you can write a test.py file, put it in some directory, it will be interpreted as Python code. A bit unlike PHP, you have to have this main function which takes a request object and a response object. So in this example here, we use the request object to inspect the query parameters of the request, so this request.get thing, which again, sort of familiar if you've used PHP before. So in this case, if there's a content type parameter that's been sent, then we build up a list of headers from the get parameters. And similarly, at the bottom here, the body is set based on either the get parameters or some default value. And in this case, we don't actually use the response object. We just return a list of headers and the body we want to send, and that's all you need to do. In a more complicated case, we could actually use the response object to get control right down to the actual socket level. So if we want, that will allow us to send any arbitrary byte over the wire with any arbitrary timing. So that basically meets our use cases. There's a few other cool features that we decided we needed for writing portable tests. So the one at the top here, we have this var server SSL equals blah thing, is a kind of substitution syntax, which allows us to run the tests on different host names without having to kind of rewrite them. So typically, when you run this locally, we suggest that people set up webplatform.test in their hosts file. And in that case, this curly brace hosts thing will be substituted with webplatform.test. But the W3C, for example, also runs a public web server, w3ctest.org, that hosts these same tests. And in that case, host will be w3ctest.org. And the ports will be set up. So in this case, we have ports HTTPS 0, which is the first SSL port available. And similarly, the second example here, the var server subdomain thing is setting up subdomains. We have a list of subdomains that have to be available, and this gets you a domain name. We also realized that having to write Python code, even with the simple API that we tried to design, is sometimes hard, and there's common things where you might want to avoid that. So we have this pipes query parameter, which is actually handled directly by the server. And the idea is that that's basically a set of pre-canned functions that you can use to control various aspects of the response. So in this case, it's this trickle function, and what it does here is it delays the response for 2 seconds, so that's the D2. It sends 100 bytes of the response, delays it for 1 more second, and then it sends the whole rest of the response. And there's a few of these functions for making simple things simple. And this is just an example of what it looks like when it's working. This is actually running from the public web server. But you can see it's testing cross-origin requests here. And you can sort of see actually the person who wrote these tests put the server name in the test title, although they did it using substitution syntax. So you can actually see in this case that it's running on w3ctest.org. But if I ran this on my local machine, that would all be running on webplatform.test. There would be no access to this external server, even though I'm testing cross-origin. OK, so that's my sort of very brief introduction to writing tests for webplatform.test. But it's also important to be able to run tests. And so the very simplest thing you can do is, well, I can load a test in the browser. I can script the browser. So let's script the browser to load tests. And that's the first runner that we have, is just a simple in-browser runner that will load a test page using JavaScript, get the results back from the framework, load the next test page, and so on and so forth. And that's OK as far as it goes. And in fact, if the W3C has used it to do some implementation reports for standards they're working on. I think there's a HTML5 implementation report that has been generated using this tool. But it's not really something that you'd want to use in your continuous integration system, right? So I've talked about testing. Given the subject of the conference, it seems only fair to go on to automation. How can we go from something simple like this to something that's actually production quality? Well, when trying to do this, there's some unique problems, or at least compared to the other test suites we have at Mozilla, that come from trying to use a test suite from upstream. So these tests are being constantly updated. We might get 3 or 4 every day, new submissions that get merged. And we want to track those updates. We don't want to end up 6 months behind because we don't have some automated way of pulling in new updates. And that's what tends to happen if you import test suites. I've found that you import it once and then people forget about it, and then 6 months later you're like, oh, okay, we're not testing the right thing anymore. We can't actually edit the tests, because if we go around editing the test, then every time we want to import stuff, we suddenly have merge conflicts all over the place, and that requires a human. We don't really want to require a human to be involved every time we update the test. So we can't do the typical thing of marking a test as skip or to do in the test file. And because we're importing these tests, we can't guarantee anything about the tests themselves. So the typical policy at Mozilla is all tests must pass. They're regression tests, they're expected to pass. But these tests, they're not regression tests, they can fail. Well, okay, fair enough, that's sort of not that hard to deal with. But they can crash the browser, they can hang the browser. This is a bit harder to deal with. We can't just have something sitting in browser if we can expect the browser to crash every so often. So we need to do better. And the solution to this was wptrunner, which is a Python-based harness for running these tests. And the key design decision here was that we want to run these tests by remote control. Rather than having anything sitting inside the browser, we want to control the browser externally from Python, so that if a test does crash the browser, we can detect that that's happened, and we can keep going. And similarly, if it's hung, we can time out the test, kill the browser, and keep going. To deal with this problem that we don't know what the results are supposed to be, we actually store them all externally. So this turns out to be a surprisingly complicated problem. This was actually one of the hardest problems of all to solve, because your sort of natural reaction might be, that sounds like it should go in a database, right? We have a list of test results. Well, the problem is we want this to be stored with the code, really, because every commit of Gecko might have a different set of expected results as people fix bugs, create bugs, no, hopefully fix bugs. And we want it to live in the version control system, and we want it to be human editable. Obviously, supporting Gecko is necessary. That's sort of the point of me working on this, to get them running at Mozilla. But I said we were testing for interoperability, so wouldn't it be better if we could have it running in all browsers? So Servo, I already mentioned, but also Firefox OS. And then why not Chrome? Why not Internet Explorer? Why not Safari? Why not any other browser you mentioned? And in fact, all these browsers that are listed here, it does already work in. So for a remote control protocol, it turns out that WebDriver, which I guess a lot of people have already used, is a rather obvious choice, because it's already supported by a lot of these browsers. So this is a kind of schema of the design that we ended up with. So I can't really point here, which is a bit unfortunate. But the input we have is basically a test manifest, which comes from Web Platform Tests, and an expectation file, which we store in the Gecko repository, telling us whether the test should pass or fail. The output we have is a set of log files, and then we have certain internal components, which I'll talk about a bit more in a minute. So the test manifest is very simple. It looks like this. It's just a big JSON file that lists all the tests and a little bit of metadata, like does this test require a long timeout. The only interesting thing here is that this is all generated automatically from the test files themselves. So we don't ever require anyone to write any metadata about the tests. Because if you need people to write metadata, they tend to get it wrong, or it gets outdated, or whatever. So this is all passed out of the test files. The expectation file is a bit more interesting. So to solve this problem of, well, what's a line-oriented format that meets all the requirements, I ended up sort of inventing this sort of novel format, which may have been a stupid idea. Maybe somebody has a better suggestion for me, I don't know. But what we have here is basically an ini-like file, but it's a bit more complicated than that. So each test that has at least one non-passing result gets its own file, and then at the sort of top level, we list all the sort of top-level tests. So here we have utf16be.html. In theory, if we had a test with the same file name but a different query string, for example, then we could have two of these in the same file. We have the type of the test, and then skipping down a little bit, we have this getting div item ID, and that's a subtest from this main parent test. And you can see that the expected result from that subtest is to fail. What's a bit more interesting is the second subtest at the bottom of the screen, which is got this expected result. Well, by default, it's expected to fail, but on the line before, we have something a bit more interesting. If we're running in a debug build and the OS is Linux, then it's instead times out. So we have these inline conditional statements that we can use to set these on a per-platform basis. So there are different approaches that we could have taken to this, but this was fairly flexible and sort of matched something that Mozilla has had success with in other areas, sort of conditional statements, rather than having like a different expectation file for every combination of platform and whatever we're running in our continuous integration system. Similarly, we can use these files to disable the test. So right at the top level, you can see we have this condition. If we're running it on Mac, then it's disabled. And the right-hand side, well, it's just a bug number here. It's not actually used by the runner for any purpose. And the point of this is that we can check into version control, and we can rather easily edit it. OK, then to get it to run in multiple browsers, we have this simple browser abstraction, and this just controls starting and stopping the browser and checking if it's alive or not. But it turns out that this is actually all you need to get a vast amount of the functionality needed to run across multiple browsers. Just implement this API for every browser. There is a little bit more you need, because it turns out that I said, let's just use WebDriver. Well, it's not quite as simple as just use WebDriver, because every implementation of WebDriver is a bit different. Mozilla has Marionette, which is not quite compatible with WebDriver, but is a bit better for us. So we also have this concept of an executor class, and there's one executor per remote protocol, basically, and per test type. And it's basically where the magic happens. It actually tells the browser, now run this test and convert the results back to the internal format. But this architecture with these just 2 points of abstraction has been very successful. So for example, when we added Firefox OS support, where the test runner and the browser are running on completely different machines, one's a mobile device and one's a host computer, we found that it only takes, well, we already had some libraries that we could reuse, but it only takes about 250 lines of code to support Firefox OS, excluding those libraries. This is the output. It's not very interesting. It's just JSON delimited, line delimited JSON telling us what happened in every single test. Very useful to have a machine passable format. Mozilla used to use a lot of regex readable formats. That was terrible. Don't do that. OK, so now I hope we have some videos to show quickly. OK, so this is very hard to see, but this is hopefully running it in Firefox, just as a developer would. There's a little pause, and then some tests start running. And you can maybe just about make out on the right-hand side there that it's telling you the result of every test. It looks like this test here probably times out or something. And then at the end, we get a summary. And in that case, actually, because we have expectation data, it says all the tests got the expected result, even though one of them timed out. We can also run it in Chrome. So again, I just need to wait for the video to happen. And one of the interesting things that you'll see here is that it's actually designed so that we can have more than one process running the tests at the same time. So here we're controlling 2 instances of Chrome simultaneously and getting them to run different tests. And that's pretty useful if there's something like a timeout, because here we have 2 tests that are timing out for some reason. They can time out in parallel much faster. And that's pretty cool that we can do that. It turns out that using multiprocessing in Python or whatever adds a surprising amount of complexity to what seemed like a very simple idea. OK, so I've talked about whether it works or not. It works, but does it work well enough to use in a continuous integration system? Well, the good news is that finally it does. It's now running on every commit to Mozilla-inbound, so I don't know how many commits that is a day, but I think it's certainly hundreds of commits a week or something. You can maybe see this. So on the very left of this picture, you can see there's a W and then some green 1, 2, 3, 4. That means that all the tests are getting the expected results in all these check-ins. And this is just it running on Linux, but now we also have it running on Windows too. It took a while to get here. For a long time, I was explaining to people that the basic purpose of my job was to turn orange W's into green W's. Because it turns out that when you run tests, you find out that a lot of them were flaky. These were tests that had never really been run in continuous integration before, and a lot of the effort was just getting them up to that quality standard. And you can see we still have problems. Right at the bottom of the screen, there's an orange 4 with a little star by it, and that means that somebody's come along and said, we know that's a flaky test, so even though that test run has failed, it's okay. It's okay. We've also got it running on Firefox OS devices. And this is forming part of the certification suite that we send out to people making Firefox OS phones to check that they didn't break anything that we didn't want them to break. So there's a video of this too, and I will talk over the video, because it turns out that a lot of getting this to run is watching the phone reboot a lot of times. So it's kind of my hobby. Yeah, so we can use this to check that when people are shipping Firefox OS phones, they're not accidentally regressing support for the web platform because of changes that they've made in their local branch of Gecko. So this does a lot of setup initially to check. Here it's checking, can I connect to the host computer? OK, I can connect to the host computer. Let's restart again and actually run the test. But yeah, I think people were quite surprised with this architecture, how easy it was to get these running on a separate device. I think with some of the architectures we'd used before, where we had tests controlled by JavaScript in the browser, they were having quite a lot of difficulty porting that to mobile devices. OK, so now it's actually started, and I think it's going to run some tests. It installs a little very simple app to run the tests in, and here it is running some tests. And yeah, that was a few tests. Not very exciting to watch, really. So that's what we have today. But actually, there's a lot more that we want to do with this. So one thing we want to do, I said that we're using WebDriver. Well, WebDriver itself is being standardized at the W3C. So wouldn't it be great if we were sort of using WebDriver to test WebDriver in some sort of meta-circular way? Well, it's not quite going to be like that, but we want to add WebDriver spec tests to the Web Platform Test Repository. And so if you're working with this stuff and you're finding incompatibilities between different WebDriver implementations, this is something where we can take test cases. What's more interesting than that, I think, is that we're going to try and use WebDriver to replace manual tests that we currently have in the repository. So a number of things, even in like the content window of a web browser, you can't test using automatic means. For example, like things that require like trusted user input are quite difficult. So like drag and drop or input type equals file or whatever. But using WebDriver, we can often automate those things. So something that Andreas Tolfsen has been working on, and he's here if you want to speak to him later, is having an in-browser JavaScript API to WebDriver that calls back into wptserve to cause something to happen in the browser that you first thought of, if you see what I mean. So you write some code like, give me a trusted click event in JavaScript. It asks via XML HTTP request the server to generate a trusted click event, and it uses WebDriver to actually perform that click. So you can write the test completely in JavaScript, but they are accessing this external server. And of course, we want more of everything. We want more platforms, more browsers, test types. We want to test more different specifications. And this is something that everybody can contribute to. So to circle back to my original point, the web is tremendously important. And we're doing a lot of good work in adding extra APIs to the web, to adding better layout primitives to the web, Flexbox and so on. And we have to, if we want to keep pushing it forward, if we want to write our browser mobile operating system in HTML, if we want to write any kind of native-like UI in HTML, we have to keep making it better. But adding new features is no use if we don't make sure that they're implemented well so that people can actually use them in a reliable way cross-browser. And the idea of web platform tests is that anybody can come along and they can say, okay, I found this thing that doesn't work for me. I can contribute back to that, and I can have it running through wptrunner in the continuous integration system of, hopefully in the future, any web browser, but certainly today already, the Firefox continuous integration system, within a few days or a few hours of submitting that test. That's really where we want to go for this. And I think that will give us a really big lever for improving the web platform in the future. And allow us to really maintain the velocity of improvement that we need to keep up with other toolkits. Excellent. Thank you.
We have some time for questions? Okay. Any live questions?
For the web platform tests, it often happens that you're writing tests for a standard that is still developing. Case in point, for instance, WebRTC or other standards and stuff. So how do you deal with that? I mean, when the standard changes, then presumably the test should change as well. Like, how do you deal with that in continuous integration?
Yeah, so we don't have like a great protocol for that. But I think the idea is that once people are running the tests, you notice those things quickly. Like if you're running the tests every day and then the standard changes, presumably at some point you're updating your implementation and you notice, oh, these tests, they're out of date, we need to change them, we need to remove them, whatever. So you actually have that incentive. Before, the situation was that, we had these tests, but people weren't really running them. And so there was no way, nobody was incentivized to actually do the work to update the tests. I think running the tests is key to having good tests.
Thank you.
Oh, sorry.
So you showed us that there's this a way of writing tests, right? But it was not clear how the test oracle is written, right? How do you specify what is expected, what is not? Because with web platform, many of the times, it's to do with the rendering or how it was rendered or how the layout of the page was, right? So how do you specify those complicated, oracles in your test?
So for testing rendering, we have a different test type. So I talked about JavaScript tests. We also have something called a reference test. And what you do there is you create a page that should, you create 2 pages that should render the same way, but using different techniques. So typically one would be the thing that you're trying to test. Like say you're trying to test Flexbox, then you might generate some complicated thing using Flexbox. And then one might be a simple page that you generate using just normal CSS positioning. And as long as they look the same, then the tests pass. And the advantage of that technique is that it's very robust to changes in the browser that shouldn't affect the test. So one typical problem you have with testing rendering is that if you have, say, some text on the page, and then you update your layout engine to anti-alias the text differently, then all your tests start failing. But if you're always running the 2 tests together in the same version of the layout engine, then changes that don't affect the test in a sort of normative way aren't going to mean that you have to update all your master screenshots.
Okay, thanks.